All right, example 4. Wrinkle fighter could help reduce excessive sweating tells of a study where researchers gave 322 patients underarm injections of either Botox or water. A month later, 75% of the Botox users reported a significant decrease in sweating, compared with a quarter of the placebo. So the explanation provided is that Botox seems to temporarily paralyze the nerve that stimulates sweat glands. Let's run 1,000 simulations using the Rossman chance app. How likely could random chance explain the results of this table? So there's the Rossman chance. I'll enter the table, 121, 40, 40, 121. Again, click the Use Table button. And we see the difference between them is about 50%. So there's a big difference between those. Do 1,000 simulations. And then count samples that are greater than or equal to 0.503. And in this case, not a single simulation was even close. You see all the simulations are right here. The difference in the proportions is over here. This is what random chance looks like. This is our sample. Our sample had nothing to do with random chance. I can do another 1,000. Let's get to 10,000. 8, 9, 10,000 simulations. Not one was even close to the actual difference in these proportions. So, in this case, how likely could random chance explain the results? It would be very, very tiny. It's not technically 0, but it is very tiny. About 0. Suppose instead we were to do the same results, except the sample size was 8 instead of 322. So what if instead I had 3, 1, 1, 3? So essentially the same proportions. You can see that this graph here looks pretty much the same. Observance 50%. I run 1,000. And I want to get 0.500 count. And in this case, it occurred about 23.5%, 23.4%. So there's still the same big difference, but you can see that much smaller sample. Random chance is much more likely to be an explanation. So how likely could random chance explain the results? Well, from our simulation, it was about 23.4%. And, essentially it was the same difference in proportions, but because it's just much smaller sample size than the previous example, it made random chance a much better explanation for what we saw. Okay. The BBC News website reported in 2003 that tight ties could damage eyesight, citing that researchers from the New York Eye and Ear Infirmary in New York tested 40 men, half of whom were healthy and half of whom had already been diagnosed with glaucoma. Their intraocular pressure was measured, and then they were asked to put on a slightly uncomfortable tie for 3 minutes. They were tested again, and 60% of the glaucoma patients and 70% of the healthy patients were found to have a significant rise in pressure. So as soon as the ties were removed, the pressure fell again. The researchers warned that long-term pressure rises have been linked to the condition glaucoma, which is the most common cause of irreversible blindness in the world. Okay, so let's first evaluate the study on the 4 principles of experiment design: controlling, randomizing, replicating, and blocking. In terms of controlling, yes, we can assume that, assuming that the intraocular pressure was measured the same for all 40 men. In terms of randomizing, there's no mention of random selection or random assignment. We need to be careful about assuming that there is. So it's a bit iffy. Replicating, well, no, it was only 40 men, so this is a fairly small sample. And blocking is by whether men were diagnosed with glaucoma. Recall, blocking is when you do a non-random division, breakup of your group. So we have 40 men. We broke them up in terms of those that were healthy, and those with glaucoma. And then we did treatment control. Right, anyway, what is the difference in the proportions in the significant rises in pressure between the two groups? Well, 70% of healthy patients were found to have a significant rise in pressure. Glaucoma patients were found to have a significant rise in pressure. So the difference in proportions is 10%. Finally, so if I run 1,000 simulations, go to Rossman chance, and I'll enter the original results, which were 14, 6, 12, 8. Use the table, and see the observed difference is 11%. So run 1,000 simulations, and I get 0.110 count, and I see that the count 38%. So that tells me that the explanation for random chance is about 38%. So not much less random than flipping one coin. So random chance is a pretty good explanation for the difference between healthy patients and glaucoma patients. Okay, last example. An internet report from January 2005 is titled, Study, Anti-Seizure Drug Reduces Drinking in Bipolar Alcoholics. This table is consistent with results mentioned in the report, which explains that drug and placebo takers were questioned after 6 months to see if they had engaged in heavy drinking, which is 5+ drinks daily for men, 4+ drinks daily for women. So let's run 1,000 simulations using the Rossman chance applet. How likely could random chance explain the results of this difference in proportions? So, again, enter the table data. So 14, 15, 18, 7. Click Use Table. The difference you see is 0.244. So do 1,000 simulations. 0.244. Count. And the difference in terms of random chance, the probability is about 4%. So possible, but not likely. So what do the results suggest about the effectiveness of the drug? Well, based on the results, it was possible random chance could explain the results, but it's not likely. So a better explanation is that this drug, this valproate, is actually explaining the difference in these proportions.